Mercury from Mariner 10. The MDISC image, the camera took over 1,200 images during the flyby. The mass instrument, which is what I work with, did a successful test of the sodium exosphere very far out from the planet's surface. We were looking into what they call the tail region. If you have the sun over here, Mercury here, as we were coming in, we started looking back here to see what is streaming off the planet from the solar wind. And we could detect it out quite far. We also saw calcium in the exosphere. And the mercury laser altimeter, also, we drew a line, a little pencil-thin line across the planet's surface as we were near it. And we have a nice little profile, it's a thin profile, of what some of the surface topography looks like. This is an image taken with the MDISC camera about 9 minutes after the closest approach. And what I'd like you to see here is watch this set of craters here, and then this is 4 minutes later. Those are the same set of craters. You see the angle that we came in on, we're looking nearly sideways to them. And then just a few minutes later, we're looking pretty much straight down on that same field of view of the planet's surface. So this is the departure image that we have of Mercury. And everything to the left of the red line is brand new terrain that we had never imaged before. Everything to the right is what Mariner 10 had seen. So we got this whole chunk of Mercury that the science teams were just gaga over. And zooming in a little bit, I want to zoom in on this part right here and give you just a taste of what we can see with just this one image. We can put time, we can see relative time events on Mercury in this one image. You can see 5 different events that have happened over the course of Mercury's existence. We can't put numbers to those times or how many years ago or millions or billions of years ago these things happened. But we can see there's a large crater right here. It's almost saturated with everything else. It's almost faded into the background. It's an early crater from the heavy bombardment period in our solar system. And so this thing formed first. After that, you had other craters that were formed from subsequent impacts after this crater cooled off. Then there's an uplift area right through here where Mercury's surface seemed to have buckled a little bit. And we see this a lot across the surface of Mercury, where we have all these scarps or rupees. They're giant uplift areas. And then we have the Eminescu crater here, and you can see there's a train of secondary craters from the ejecta blanket from this crater here. And then this crater here is the youngest one in the bunch. Going back to Eminescu, you see these secondary blankets, the ejecta blanket covers and actually overlays on top of everything else that's happened. So the Eminescu crater is younger still than the uplift or these other craters or the main first crater here. And then this crater, this young crater here, which is of a Chinese name that I can't pronounce, you can see this gray blanket of material extends off in all directions and actually goes across the Eminescu crater also. So that's the youngest impact event in this image. This is the Eminescu crater right here, and you can see the ejecta blanket from the smaller impact crater just off to the side. And if you can pronounce that, then you win. I was told it's Zhao or something like that, but again, I don't speak Chinese. I do better Italian, and it's not.
Sounds like a professor ahead.
But you can see the ejecta blanket is this nice grayish, light gray area that extends out all over the place. And we know this is pretty young since it hasn't space weathered away to resemble the rest of the background on Mercury here. Going off to the terminator from that overview of Mercury, we have this Sveinsdottir crater right here, and And there's this giant rupees right here called the Beagle rupees. It's the largest one we know of on Mercury right now. It's over 400 miles long. And then you've got these other subsequent craters right here. This is looking towards the northern hemisphere of Mercury, and you see it's got some craters, but there's a lot of plains areas. It's not crater on top of crater on top of crater. There's a lot of flat plains areas. Whereas in the southern hemisphere, it's just bombarded to heck with craters, just littered with craters, which again is indicative of things that happened in the beginning with Mercury. The bombardment period was more intense from the south than from the north. We don't know why yet, but this is just more clues to the formation of our solar system. And looking down to some of these craters, you can see that this one right here and this one right here have dark material around them. And this material is real. What it is, we don't know. It's either subsurface strata that was ejected during the impact event of these two craters, or it was material that was impact melted and then thrown out from those impact events. And we see these dark halo craters periodically around Mercury. Drifting quickly to the mass instrument and looking at the sodium tail, you see the sodium detection here. It tapers off fairly rapidly once we get pretty far out, but we can see it. We had detections all the way out here, several Mercury diameters away from the planet. And we, of course, our magnetometer did a magnetic reading of the magnetic field, and it detected it, and it resembled that right there, which is very, very similar to what Mariner 10 saw during its flybys, and it seems to indicate that it is indeed a global magnetic field. The laser altimeter drew this line right here, and this is the very, very exaggerated graph showing the different craters. Some of the craters here go down about 3 kilometers, and the graph is very compressed in this direction. So these are actually much more stretched out if you do it from one, vertical to horizontal. The plan for the laser altimeter when we're in orbit is to start just painting Mercury's surface as much as possible, as far as the laser will reach, and try to get a surface topography of what Mercury looks like in 3D, and correspond that with all the images and everything else that we'll be taking. This is the Raditlati crater, impact basin actually. And what's interesting here is these concentric ring troughs, these extensional troughs right here. These things occurred after the impact basin filled in with this volcanic lava material, and then it cooled off, and then it started cracking in these concentric rings. So far, we've only seen this on 3 areas on Mercury: in the Raditlati impact basin, in the Rembrandt impact basin, and in the Chloris basin. Speaking of the Chloris basin, this image was taken with Mariner 10 or Messenger. There was a test. Okay, you failed. This is the Mariner 10 image I showed you guys earlier. I'd let you redeem yourselves. This image over here was taken with which spacecraft? Okay, yeah. The yellow dashed circle here is what the scientists had estimated the size of the Chloris basin based on the Mariner 10 image alone. It's figured 800 miles or so across. The blue circle here is what we now know of the Chloris basin given the Messenger view of it, since we can see the entire thing. It's about 960 miles across, which is larger than it is from Miami to Washington, D.C., just to give you a scale. And there's a lot of happenings inside the Chloris basin. If we go back real quick, you see there's these 3 craters here we'll go visit first. There's this black crater here. There's this light crater here. This is the center point here. There's a white spot over here, which is pretty cool. There's this interesting feature right here, which I will talk about. How do these things look to you guys? Are they too dark? Is that helping any? Because to me it looks really dark. And on the screen here it looks nice. It's really dark. Well, there's 3 craters right here, and if the contrasts were a little different, you see this was a moderately bright crater with a dark ring, and this one also with a dark halo, but this one has a white material on the interior. And this crater right here is only about 40 miles across, which will give you an idea that, you know, within tens of miles from each other, we see a lot of different geological features inside the surface of Mercury here. This is the Cunningham crater. It's a relatively newish crater, as you can tell from the ejected blanket. It's still fairly light. It is starting to fade from space weathering. And then this guy right here is a very new impact site. Very new. Again, I couldn't tell you if it was from 10 years ago or 100 years ago or 1,000 years ago or what it was. We don't know that yet, but relative to everything else in the picture, this is very new.
You also got a face there.
And then we got this crater right here, which is another, the outer edge here is all this dark material, and then the inside is all this very, very light material. And unfortunately, it's hard to see, much better to see it on my screen. Imagine all this is a light gray, then you got this black crater right here, remains black. And again, this is stuff that either happened from the impact event itself or was excavated from the impact event. This crater here is called Atche. And this spot right here is the center of the Caloris Basin. And you can see there's extension troughs radiating outward from the center area. And superimposed on the center point, which is actually right here, is this secondary crater. This secondary crater is not associated with the impact of the Caloris Basin or the formation of the Caloris Basin itself. It's a serendipitous secondary impact that just happened to fall right there and actually accentuated some of the extensional troughs here. And the Cunningham crater, what I showed you a little bit ago, is right here next to it. This is a close-up look of the Apollodorus crater, and these are called the Pantheon fossae, this radiating troughs here. And this is an unusual crater. This is not an impact crater. This is a volcanic caldera. And this is the whole dome from the volcanic caldera. And these are impact craters that happened around it. And this right here, you guys have heard of the face on Mars, right? Yeah. Yeah. We have Bigfoot right there. His toes, his heel.
Yeah, I can see it.
So, but these are vents from this volcanic caldera. So there was volcanic activity on Mars at some point in the past. I'm sorry, Mercury. I'm tired. This is not the only volcanic caldera that we have seen on Mercury. We've seen over a dozen of these things now, just from the flyby images. Now, can you guys see the color in this? This is your true color, fantastic, brilliant image of Mercury. It's about as colorful as it gets to your eye. I'll show you some more colorful images coming up. The second flyby took us around this backside here, which would have already been seen, but we would get a glimpse of this little area here on the flyby. So we would see a little bit more of the surface of Mercury than we had seen before. Again, this is the timeline, the high-level timeline, mid-level, and then the actual tens of minutes through the flyby itself and all the high-level activity that was going on. And the approach images, as you get closer and closer, you see there's a white spot here that's beginning to appear. This is a whole sliver of Mercury that we hadn't seen before. So we got this new crater up here. This is a white spot here, and then there's a lot of stuff that's going on along the edge here. So just taking a quick tour down the limb, you see towards the northern end here is, again, it's a lot of flat plain areas with some cratering. Going down, there's that new light area, that white spot here. Coming down further, you see there's a scarp right here beginning to roll. And it continues down here, interrupted by this crater here, and it continues on down before fading out. And as you get down to the southern hemisphere, you see there's more and more craters. This is quickly just the results. Again, this was an even more accurate flyby, if we could possibly have it, than the first flyby was. We had imaged at this point about 90% of the surface of Mercury in at a scale of 1 kilometer or better. Since we passed on another side of Mercury, we were able to verify that the magnetic field it seems to be very global, and we detected magnesium in the exosphere for the very first time. It's also the first time we tried looking for it, but that's beside the point. This is what we knew of the surface of Mercury from Mariner 10. Then this is from the first flyby, and then this is from the second flyby. You see, we aren't getting anything in the poles, and we have this little sliver left here, and the little sliver right there, yet to fill in, which we will actually get to cover in the third flyby. You guys remember yeah, good. Oh, 5 minutes? Oh, okay. Earlier I mentioned to you guys the great northern crater, the great southern crater from the VLA images. This is the great northern crater. You can see the rays radiating out. They go more than halfway across the planet from this impact. That's the northern crater. There's a scarp right here that cuts through this crater. I've got like 5 minutes, so I'm just going to start rushing through some of this. Sorry. We got this same scarp is right here. The earlier one was looking at it sideways. This is looking more face down. There you can see some of the rays from that northern impact basin. And hard to see here, there's a crater here that's dark ringed, and then just tens of miles away is a white crater with whitish material. A black ring crater right here. Again, the rays can be seen coming down here. And that same black ring crater. This is an interesting black rayed crater. Most of the black ring craters have a uniform blanket of black material, either haloing the entire crater or just off to the side. This is interestingly cast off in this little fan pattern. This is the southern giant crater from the radar images. And this is one of the rays here, and some scarps right here. There's a scarp. This is going back to that phase angle thing I mentioned earlier. This is the Mariner 10 messenger image, the same area. This crater set right here is this right here. You see that little one there, one right there. In full-on face view, we can see the ray features from this crater, but this crater right here just vanishes. There's no relief to it at all. Once on a terminator, we can see the shadows, but all the ray features disappear. So one of the mandates we're going to be doing with messengers when we're in orbit, we're going to be looking at the surface both along the terminator when we have shadow and when it's in full sun, so we can see the differences and then put the two together. This is reversing the two. This is Mariner 10 along the terminator, and this is face-on full-view sun, a messenger. This ray feature here is virtually gone in the Mariner 10 data, but we can see it right here, as are this crater right here. Sodium, we detected sodium, as I mentioned earlier. We got our magnesium count right there. The flyby 1 and 2 were on opposite sides, and this is the Mariner 10 flybys, and this is the two flybys from Messenger superimposed of the magnetic field reading. And again, the laser altimeter, which if you note real quick, the crater bottoms on this side of this scarp right here are all tilted upper left to lower right, and the ones on this side are all flat, which indicates that the area of the planet right here was uplifted a few degrees. And this is the Rembrandt impact basin right here. It's the second largest impact basin on Mercury's surface. To give you an idea of size, this is Northeast America. So if it hits New York, you guys are still fine. I'm right there. So, and remember, the Caloris Basin is much bigger. This is only 400 miles or so across. This is a false color image. What we're doing here is we're using different high-end color when we're looking at the planet's surface and getting different reflectance off of it. We can't assign any mineralogy to the colors yet. That's to come when we start using a spectrometer. But the different colors do mean different mineralogy features on the surface of the planet. And it seems more or less that anything that's yellow is going to be more volcanic in nature, and anything blue is non-volcanic in nature. So this is the color image I showed you earlier, and then this is the false color enhanced image showing you the mineralogical distribution on the surface. And it's a very, very interesting planet to look at. The third flyby was not as scientifically successful as we might have liked it to have been, but at an engineering standpoint, everything performed properly in that we performed a flyby without landing. We were able to slow down and put ourselves up for going into orbit this month. The science side of it, unfortunately, about partway through the back part right here, when we were in total eclipse from both the sun and Earth, the instrumentation, the computer said, hey, I don't have enough power. I'm going to run out of power. I better shut everything down now. 10 seconds later, it came into the sun.
Oh, no.
The engineer who had programmed that parameter was being very conservative because he didn't want things to run out too early, and we lost everything on the back half of the departure part of the flyby. However, on the approach, we still got everything we were going for. We still got our close approach. We finished imaging the mid-latitude and equatorial regions. We got our final gravity assist from Mercury to slow us down properly. We discovered new volcanic caldera on the planet. We observed seasonal effects with the exosphere. We still made scientific discoveries despite the fact we didn't get all the cool stuff. We were going to start doing the spectroscopic imaging of the planet on the backside, and we didn't get to do that. So we can start putting chemicals and minerals to those colors that I was showing you earlier. Alas, we didn't get to do that. Anyway, approaching, you see the white spot right there is the same white spot I showed you in the previous flyby 2. You see it's right here. We're making all kinds of discoveries here. This whole region, we'd never seen anything there before. So now we can fill in this spot right here. And this is the flyby 2 image of that crater. This is the flyby 3, and looking at it, it's not a crater. It's a volcanic caldera. Just to show you that, as we're looking at things, that not everything appears to what it seems to be. I know I'm running way out of time here. Large impact basin right below the volcanic caldera up here that we hadn't seen before. And you see the concentric ring pattern in here. And then this is the false color image. This is the volcanic caldera, and this is that large crater. The sodium tail seems to have virtually vanished in this flyby. If you stretch it out by a factor of 5 compared to the second flyby non-stretched, it barely comes out, but for some reason it just disappeared. So we think there's seasonal action going on Mercury. And, calcium detections from the spectrometer. And some more of the sources. This is flyby 3, this is flyby 2 of the same crater here. There's a rupees, or scarp right in the middle here. You can see it's nearly in the shadow right here. And this is a color image of the approach from flyby 3. and the false color image. You can see the bright volcanic caldera right up here. And the final departure image after we got out of safe mode. This is, quickly, this is actually Earth and the Moon, as seen from Mercury's orbit. And the image is actually flipped upside down. This is Scorpio over here. You know, Antares is off the side here, head of Scorpio, Earth and Moon. What we did last year was we did a reverse of what the Voyager did. The Voyager spacecraft, as it went out, Carl Sagan said, hey, let's look back and take a portrait of the solar system. So they took an image of the solar system. What we did last year is we looked out, and we took an image of the solar system. And there you go. Jupiter right here. You can see the 4 Galilean moons. Earth and Moon up here. Venus. Neptune, Uranus are too faint to actually be picked up in with the MDIS camera, but we imaged the fields that they were in. Uranus is right up in there.
Was there any magnification on that?
There's some, but I don't know what it is. The moons, which you can't see in this because of the contrast. Well, I can see it on my screen fine. There's 4 moons. Trust me, they're there. You see one right there. And insertion happens in just a couple weeks. We will be the first spacecraft to go into orbit around Mercury. We will be taking the first week, once we're in orbit, just verifying that things are working right, bringing things up slowly. Right now, all the instrumentation is off. It was turned off in mid-February. So we'll have no approach images of Mercury while we're going into orbit, or before. We're going to start slowly bringing various things up and making sure that things are functioning fine. We'll just bring the instruments up and see that things are still functioning after we've done the burn. I want to do, real quick, go away. I'll show you a quick movie while I'm talking. That's going to represent the orbital insertion. That's going to be a 15-minute burn where we're firing the engine to slow us down and put us into our elliptical orbit. Once we're in orbit, we're going, as I said, we'll be going around the planet every 12 hours. We'll be turning things on. A week after we have gone into orbit, we will begin doing some engineering analysis of everything. We'll be doing some test imaging. We'll be doing some test spectra. We'll be just exercising the instruments on a science level, but we will not be doing any pointed spacecraft imaging. If we're pointing at the planet when we take the data, we're pointing at the planet. If we're not, we're not. The guidance and control teams don't want to do that until the second week after we're in orbit to make sure other things, checks and balances that they have to check are okay. Where's this thing at? And then, so 2 weeks after we go into orbit, we will begin doing in earnest science observations. And within a week of that, maybe even sooner, you should start seeing on the Messenger website a daily image. Meanwhile, if you want, you can go to the planetary names, wrugs.gov, to get maps of Mercury as they are now. Oh, sorry, did you want to get that? I go back. But we'll be putting up, I think the plan is to do a daily image from here on out for at least a few months, and then do weekly images from the releases that we take, of the images that we get down from the spacecraft as we get them down. It takes time to get things down from the spacecraft. Right now it takes, we're at a round-trip light time of about 20 minutes. It takes us 10 minutes to send a signal out and 10 more minutes before we get a reply back. So we have an RTLT of 20 minutes right now. And we get downlinks 2 or 3 times a day. The website will have a daily image that you can go and check out. Other instruments should be putting up also findings as they get through their analysis of their data. And the Bepi-Colombo mission is slated to launch in 2014. It's going to take them about 6 years to get there. They're planning on going into a slightly different, more circular, meaning less elliptical than we are orbit. So they should be more stable. And they're actually European Space Agency, Japanese Space Agency combined mission. So there are actually two spacecraft here. There's actually three spacecraft. There's two orbiters and one lander at this point in time. That's the plan. And this is the last slide I have for you. Down at the bottom is the website for our mission. And from that link, you can go to the link called Gallery,